Hi, everybody. I hope you're doing well. Today, we are going to talk about section 8.2.5, which is completing the square. So, last week, we talked about how you can write the equation of a parabola in graphing form. So that's that f of x equals a minus times x minus h squared plus k, right? And it made it easier to find the vertex. We could also find the x-intercepts. But what we want to talk about today is how could I go from the standard form to this graphing form? So that's what we're going to talk about today. So you're going to use the zero product property to rewrite this equation to find the x-intercepts and to find the vertex. Right? So you should be writing this down as we go so that you have it to refer to. Okay. So zero product property means we're going to factor with the box. Okay, so I'm going to put my x squared there. I'm going to put my 10 here. I'm going to make my diamond pattern and see what happens. So I need two things that are going to multiply to be the same as this diagonal. So x squared times 10, or 10x squared, and add to be my middle, which is 8x. Okay, so take a minute, think about what two numbers would multiply to be 10x squared and then also add to be 8x. So things that come to mind to me, maybe 5x and 2x, maybe 1x times 10x. But if I add either of those pairs, I don't get 8x. Okay, so then what does that mean? Okay, so you talked about this last time, that sometimes it just means that your x-intercept isn't on a nice integer or rational number, right? It's on some kind of crazy decimal. So that must be what's happening here, right? This is not factorable or unfactorable, right? So the x-intercepts just must not be very friendly numbers. All right, so you also talked last time about how you could have something in this graphing form and have it be equivalent to something in standard form. So I'm going to just tell you that I could rewrite that x squared plus 8x plus 10 like this. Okay, and last week, Miss Aponi showed you guys how to go through that process. Okay, and you also talked about how to find the x-intercepts and the vertex, and then how to be able to sketch a graph. So the vertex for this one, using our rule from last time, it's hk. So this is the form a times x minus h quantity squared plus k, and we know our vertex is hk. So in this case, remember, this is always, the h is the opposite because it says minus, but that's addition. And this is always the same. So we can very easily get the vertex using that pattern. So this is -4 and this is -6. Okay, last week you guys learned how to find the x-intercepts. So our first step is to put 0 in for y, right? Because x-intercept is when y equals 0. And then solve for x. Take a minute and go ahead and do that. Okay, so if we solve for x, I would first add the 6. So I'd have 6 equals x plus 4 squared. And then remember, to get rid of the square, the inverse is to take the square root. So I'm going to take the square root of both sides. And when I take the square root over here, it's positive or negative, and the decimal is about 2.45. And then over here, when I take the square root of x something squared, I'm left with just x plus 4. Okay, that gives me two possible equations to solve. X plus 4 equals the positive 2.45, and x plus 4 equals the negative 2.45. And then we would solve each of those for x. So here I would subtract the 4, and get negative 1.55. And here I would subtract the 4 and get negative 6.45. So I set up here that my vertex was at -4 and -6. Now I also know that my x-intercepts are at -1.550 and -6.450. Okay, and then we want to sketch the graph. Okay, and I really am going to sketch it. And I know this is how some of you are doing it on your homework because you don't have graph paper, and that's totally fine. But we want to try to be somewhat accurate. We want to make sure we're putting a scale on here. So I know my vertex is at -4, -6, so I want to kind of get pretty close to that. 2, 3, 4, 5, 6, and then so 1, 2, 3, 4, and then I want to go down 6. And then I said my intercepts were at -1.55 and -6.455. We're going to have to estimate where those are. We can't get those exactly. Okay, and then once I have those, I can sketch my parabola through. Okay, so now the next thing we want to talk about is how can I go from standard form to this graphing form, right? The graphing form is nice because I can easily tell where my vertex is and then I can get my x-intercept. So I want a way to do that on everything, right? So we're going to use a process called completing the square so that we can write it so that we have a perfect square on one side so that I can figure out what the vertex is. To do that, we're going to use our old friends, algebra tiles. So I'm going to set this equation up here using algebra tiles. I know how much you all love them. Okay, so I've got a y equals, so I'm going to start with a y. And then I got an x squared. I'm going to have 8 x's. Okay, so I've got 8 x's, and then I need 10 ones. Okay. Remember how we would have like kind of the lines on the paper, almost like when you had your mats, right? And it's that these two sides are, yucky, that those two sides are equal. All right, so what I want to do is I want to arrange this right-hand side into a square. So I'm going to have my x squared here, and then I've got 8 x's. So like think about how should you break down those x's so that I can have the same on each side of my square that I'm trying to make. Okay, so I'm going to try to get a square here, and I want to have the same here as I have here. So how am I going to have to split up that 8x? Okay, hopefully you said I need 4 on each side. Okay, because I want to have the same amount because I want it to have the same length on each side. Now I'm using tiles, and as you're working on some of these, I'm going to show you how to do it with tiles to start, and then we'll go away from that. But remember, you do have the algebra tiles as a tool in CPM that you can use. All right, so now I've got these 8 ones, and I want to fit them in. I want to make a square. So I start by putting them here. I could put them this way. Whoops, stay in line, guys. All right, I could have put them this way. It doesn't really matter. I'm going to try to put them all next to each other as best I can. All right, well, it's not a square. There's no way to get it to be a perfect square. And so what we're going to have to think about is what could I add to this side to make it into a complete square? That's why this is called completing the square, you guys. All right, so I'm going to have to add some more so that I can turn it into a complete square. So how many more do I need to add? So take a look. How many more do I need to add? Okay, on this side, I need to add right over here, right? I need to add, I'm going to just make a note of how many adding. I need to add 6 more. Okay, so I'm going to add 6 more. Now, this is an equation, and when we work with tiles, we have like legal moves. And remember, one of the legal moves is whatever you add to one side, guess what you have to do to the other side? You have to add the same amount to the other side. So I need to, on my other side, add 6. So 1, 2, 3, 4, 5, 6. 5, 6. Okay, so now those are balanced. So if I write what I have now, I have over here, I've got y plus 6, right? I've got a y. I've got plus equals. Now over here, remember how we talked about we could write things as the sum of all the tiles, or we could write it as a product. We're going to write it as a product. So on this side, I've got an x right here. I've got an x and a 1 and a 1 and a 1 and a 1. So this whole side right here is equal to x plus 4. Okay, and then on this side, I've got an x and a 1 and a 1 and a 1 and a 1, which is another x plus 4. Okay, the whole point of this was to get perfect squares, to turn it into a square. So they should be the same because it's a square. So I can write that as x plus 4, that quantity squared. Do you guys see right now how close I am to getting this into this graphing form? Okay, so think, what is the thing that I'm going to have to do to get this into this form? I'm going to subtract 6. And so then I'm left with y equals x plus 4, that quantity squared, minus 6. And that is how we're going to think about that idea of completing the square. Now, of course, we're not going to want to bust out with the tiles every single time. That is too much. But we're going to have that idea in the back of our head. Okay. And so if we wanted to look at the tiles, how I got that, remember, if I want to switch things to the other side, how I flip them over. Okay. And so that's basically what's happening. And so I have y equals, this is x plus 4 times x plus 4, x plus 4 squared, and then minus 6. All right. This was a big deal, you guys, a big deal. It might not seem like that would be a big deal, but to mathematicians, this was a really big deal. Okay, so now we're going to practice. All right, let's move all these guys out of the way. So let's take a look at this next one. We're going to complete the square on each of these functions. And the whole reason we want to do this is to figure out what the vertex is. So take a look at this one and imagine, okay, I'm going to start out with my squares and stuff, my y equals, but then I'll show you how to do it without, because I know, first of all, you don't have tiles in front of you. There are the ones, the ebook ones, but it's easier to have another way, right? 2, 4, 6. And then I've got, 7 of these guys. So think about, first of all, we want to make a square, and here we got the x squared, so we kind of want to build off of that. How do we need to split these 6 up so like I can have the same amount on each side? And start thinking too, are there any patterns that are going on here that we're going to be able to use to generalize? Okay, so what are you thinking? Half of 6 is 3, right? So I can split it up like that. And then I've got 7 of these. Okay, but, well, how many do I have to fill in to make it be a perfect square? Okay, I would need 2. And if I add 2 to one side, I have to add 2 to the other side. And then I could write this as x plus 3 times x plus 3, or x plus 3 squared. And then over here I have the y plus 2, and I'll be able to do that part where I subtract things over. All right, so let's talk about how would we do this if I didn't want to mess around with the tiles, because I just don't. So I'm going to go back to my generic rectangle that I use when I factor. Okay, we know that normally when we factor, our x squared term is here. Okay, and so we know this diagonal has to add up to be the 6x. And then we're going to think in our head, well, wait, I want them to be the same thing, right? So I have to split that 6x in half. So I'll have 3x and 3x. Well, if I were to start filling on the outside of the box, this would be an x and an x and a plus 3 and a plus 3. Oops, a plus 3. Well, if I did that, what would end up going here? Well, we would usually say, okay, 3 times 3 is 9. Okay, but wait a second. That's a 9. But over here that was only 7. Well, what do I have to add to the 7 to get to the 9? 2, right? And those were the 2 tiles that I had to add. So I have to add 2 to this side, and I have to keep it balanced, add 2 to the other side, right? So now this is equal to this box here. So I have y plus 2 equals, and this side now is x squared plus 6x plus 9. The whole reason I wanted that was because now this, right, that's what I have in this box, is equal to x plus 3 times x plus 3, or x plus 3 squared, right? And then to get it into that vertex form, we would subtract the 2 from both sides. Okay, that's separate. It's outside of the parentheses. It's not that you subtract it from the 3. It's like a whole separate thing, just like we saw in this with the tiles. So the tiles kind of help give us that image to connect to. So here is our vertex form. And so when we compare that to just the general, I keep saying vertex form, also called graphing form. I'm used to calling it vertex form. Old habits die hard. Okay, so our vertex is HK. So remember, it's the opposite, right? The opposite of what's in with the x, so -3, and this stays the same, so -2. And there's our vertex. Okay, so let's try this next one. Let's see if we can do it with this generic rectangle. Okay, so with a generic rectangle, this would be x squared. Okay, so think, what do you think is going to have to go here and here so that would add up to be 4x and, right, give me a square. So hopefully you said I need to split it into 2's, right, a 2x and a 2x. So I'm just going to build the square rectangle, or the, square over here just so you can kind of have that visual to attach to again. So this is 2x and 2x. And then what would I have to have here to complete this square? Okay, so again, if you were doing this, you would say, okay, this is x plus 2 and this is x plus 2. And now you would think, okay, well, what would this have to be here? I would need 4, this to be 4. But when I look at that, 4, here I see, wait, I had 11. Really? Whoa, look at this. If I were building this, you guys, right now, I would have 11. And wait, that's not a square at all. To get to square, I only need 4. And I have 11. What am I going to do to get rid of all these extras? I would have to subtract, right? What would I have to do to get to that 11? Right? So what I would have to do is I would have to subtract 7. And if I subtract 7 on the one side, I would have to subtract 7 on the other side. So I'd have y minus 7 equals x squared plus 4x plus 11. And then I took away the 7. So I would have x minus 7. And then I'd have x squared plus 4x plus 4, right? That's what I want to have here. And then I could write this as x plus 2 squared. And then I would add my 7 to both sides. You want to say hi, Gus? I'm recording a video, so you're going to have to go ask Daddy.
What time is it?
Buddy, go on.
What time is it?
Go on. I'm doing a lesson. You really have to go.
Okay.
So then my vertex would be, this is the opposite, and then this stays the same. Maybe I'll edit that out. Maybe I won't. We'll see. Okay, so we're almost there, guys. We're just going to do a little bit more practice with this, just because sometimes there might be different cases. That one we just did was a little different because we had to think about, oh, now we have to subtract something, right? Now, I want you to see another one. Look at this. So think about if you started setting up your box, a generic rectangle, and this is x squared. What needs to go here and here? This is a 5x, okay? What would I have to do? I mean, I could put 2 here and 2 here, but what about this? I don't have anything that's going to break this. But imagine what would that have to be? It would have to be, I'd have to split it in half. So I'd have 2.5x and 2.5x. So this is why we need another way besides just the tiles, because obviously I'm not going to cut that tile in half, right? The idea is it's always half that middle. Okay, so then this is x plus 2.5, and this is x plus 2.5, and I have 2 1s over here. But if I do this, right, if it's a perfect square, 2.5 times 2.5, that's 6.25, right? That's 6.25. Right, to make the square, I can see even with that, I don't have enough, right? 6.25, what am I going to have to add to make that work? Well, it's 6.25, but I only have 2. So what I'm going to have to add is 4.25. And here I would add 4.25. And so I have y plus 4.25 equals, well, this is x squared plus 5x plus 6.25, or, right, that's equivalent to what was in the box, or we could just call that x plus 2.5 quantity squared. And then I'm going to subtract my 4.25 and get my vertex or graphing form. Okay. And so think about, what would my vertex be for this one? So opposite here, oops, and stays the same. All right. So got a couple more just to practice, just to make sure we really got this down. So first I want you to take a look at that and think about, how would you set up your generic rectangle? And this one is given to you in function form. You might remember that from before. Remember, f of x is the same thing as just y. So when it says f of x equals, it is the same as y equals. Don't freak out when you see that notation. Okay, so I'm going to start with my box. And I've got x squared, and I've got a 10x. So what's going to have to go here and here? So those would add to be 10x and give me a square. Okay, so I've got a 5x and a 5x. So here I would have x plus 5 and x plus 5. And when I do that, in the bottom, this would have to be a 25. Well, I look over here and I see nothing. There were no ones at all. So if I were building this to make this into a perfect square, I would have to add 25 ones. I'm not going to do that with tiles right now. That's too many. Okay, but that would be the idea, is that I would have to add 25 over here, and I would have to add 25 over here to keep it balanced. Okay, so I would have f of x plus 25 equals x squared plus 10x plus 25, which you could totally write this as y instead of f of x if you want, that's fine. And then this is the same as x plus 5 squared. And then I would subtract off that 25. And then once I do that, I could say what my vertex is. So I would say my vertex is, here I would take the opposite, and then it's the same. Okay, I've got one more for you guys to try. So see if you can do this one by yourself. All right, let's see how it went. Okay, so we start with our generic rectangle, or square, right? It should be a square, really. And this is x squared. These have to add up to be 7x. Oh, that's another one where it's not a nice split, right? So we would just basically split it in half, right? 3.5x, 3.5x. So I'd have x plus 3.5, x plus 3.5. Okay, when I multiply the 3.5 by the 3.5, I get 12.25. Right, that's how many ones I would need. All right, well, I had 2 ones. I was started with 2 ones. So how many ones would I have to add so that it would work out to be 12.25, right? Because these aren't the same, and I want them to add up to be the same amount. I would have to add 10.25. And again, we have to add it to both sides. All right, so we've got f of x plus 10.25 equals x squared plus 7x plus 12.25. And then I can write that right-hand side as x plus 3.5 squared. And then subtract the 10.25. And then once you have that, you can say what your vertex is. So our vertex would be opposite, so negative 3.5, and then stays the same. Okay, I hope everybody's doing well.